In the following video, you will see an example of the power-up component of a Saxon Math lesson. During the power-up, students will typically practice math facts, skip counting, mental math skills, in addition to completing a problem-solving exercise using the Saxon Math problem-solving strategies. In the following video, you may observe the following language, direct instruction teaching strategies, and best practices. First, facts are timed and checked for accuracy and speed. Facts are checked quarterly using red and blue pens. Mental math questions are posed clearly, one at a time, and solved without paper and pencil. Problem-solving skills are appropriately modeled and scaffolded. And the teacher provides immediate feedback and corrections if needed. In this video, you will see a 4th grade math class complete the power-up during their math lesson.
Alrighty, 4th grade, let's go ahead and get those red pens ready. Everybody starting with our first fact. Get ready.
6 fourths equals 1 and 1/2.
Next.
10 eighths equals 1 and 1/4.
Next.
9 twelfths equals 3/4.
Next.
12 ninths equals 1 and 1/3.
Next.
12 tenths equals 1 and 1/5.
Next.
12 eighths equals 1 and 1/2.
Next.
8 sixths equals 1 and 1/3.
Next.
10 fourths equals 2 and 1/2.
Next.
8 twentieths equals 2 fifths.
Next.
28 equals 2 and 1/2.
Next.
24 sixths equals 4.
Next.
9 sixths equals 1 and 1/2.
Next.
15 tenths equals 1 and 1/2.
Next.
8 twelfths equals 2/3.
Next.
10 sixths equals 1 and 2/3.
Next.
16 tenths equals 1 and 3/5.
Next.
9 twelfths equals 3/4.
Next.
15 sixths equals 2 and 1/2.
Next.
10 twentieths equals 1/2.
Next.
18 twelfths equals 1 and 1/2.
Excellent. Go ahead and pick up your blue pens. Correct anything you need to. That sounded phenomenal. You should be proud of yourselves for those facts today. Alrighty, we're sitting in a nice tall ready position, getting ready for mental math. So, part A, we're talking about estimation, and it's very similar to the problem that we had yesterday. Estimate the cost of 10 and 17/100 gallons of gas at $2.69, 9/10 per gallon. I will say that again. Estimate the cost of 10 and 17/100 gallons of gas at $2.69, 9/10 per gallon. Think, 10 and 17/100 would round to what? $2.69 and 9/10 would round to what? Write it down. Try one more time. Good. Excellent. Good. Try one more time. And we have an answer written down in 10, 9, 8, try your best, 7, 6, 5, 4, 3, 2, 1. Okay, let's talk about this. If I wanted you to estimate the cost of 10 and 17/100 gallons of gas at $2.69, 9/10 per gallon, what would be the estimated cost? Chloe, $27. Everybody, what would be the estimated cost? Get ready.
$27.
I need you to correct it in blue pen. Go ahead and circle part A because we're going to come back and talk about it. Don't forget your dollar sign, okay? $27. Alrighty, we're sitting in a nice tall ready position. Eyes on me. Part B, we're talking about time. Y'all got this. How many years is half a century? Write it down. Excellent, and we're ready in 3, 2, 1. Everybody, how many years is half a century? Get ready.
50 years.
Excellent. Red circle, red X. Correct and blue pen. Alrighty, go ahead. Nice, ready position. Eyes up here. Fractional parts, part C. Can you please tell me what is 1/4 of $80? Good. Good job. Good job. Everybody, 1/4 of $80 is, get ready.
$20.
Very good. Red circle, red X. Correct and blue pen. When you're done, eyes on me. Y'all got this. You ready? Fractional parts for part D. What is 3/4 of $80? Good. Good. Everybody, 3/4 of $80 is, get ready.
$60.
I told you that you had that right in the bag. Alrighty, part E, we're talking about percents. Eyes up here. What is 50% of 1/2? Write it as a fraction. Everybody, 50% of 1/2 is, get ready.
1/4.
Very good. Go ahead and correct your work. Alrighty, part F. Now this is a long one, so sit in a nice tall ready position. Have your eyes up here. The high temperature was 37 degrees Celsius. Everybody, the high temperature was, get ready.
37 degrees Celsius.
Very good. Warm enough to go swimming. The nighttime low was 23 degrees Celsius. Everybody, the nighttime low was, get ready.
23 degrees Celsius.
Very good. What is the difference between the high and low temperatures? Good job. Good. What are you missing? There we go. Try again. If the high temperature was 37 degrees Celsius and the low temperature was 23 degrees Celsius, everybody, what is the temperature difference? Get ready.
14 degrees Celsius.
Very good. 14 degrees Celsius. Go ahead and circle part F. We're going to come back to it. Yep, 14 degrees Celsius. Alrighty, part G, calculation. It's a fun one like it was yesterday. Are you ready? Ash, eyes up here, honey. What is the square root of 64? The square root of 64 times the square root of 64. Everybody, the square root of 64 times the square root of 64 is, get ready.
64.
Very good. Go ahead and correct your work. When you're done, part H, it's time for some Roman numerals. Can you please write CL in our number system? Everybody, CL is what number? Get ready.
150.
Very good. Go ahead and correct your work. When you're done, go ahead and put your pens down because we have 2 that we need to go back to. Go ahead, read it nice, loud, and proud for us. Go ahead, Ash.
Choose an appropriate problem-solving strategy to solve this problem. Jennifer wants to use 1-inch cubes to build a larger cube with edges 3 inches long. How many 1-inch cubes will she use?
Very good. So, what information am I given in order to solve this problem today? Gia. I love that, right? I am given, right, my 3-inch dimension. What else am I given? Leo.
You're also given information that Jennifer wants to use 1-inch cubes to
Very good. So she wants to use 1-inch cubes to build a larger cube with edges 3 inches long. In the understand box, I want you to write that sentence for me. Bless you. Great job. Not yet. And we're ready in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Very good. So I know that Jennifer wants to use 1-inch cubes to build a larger cube with edges 3 inches long. What am I asked to solve for in this problem? Colton.
How many 1-inch cubes will she need?
Very good. Everybody, what are we asked to solve for in this problem? Get ready.
How many 1-inch cubes will she need?
Very good. Go ahead and write that down. If you want to abbreviate it, I'm fine with that. If you want to just write how many 1-inch cubes, question mark, that is okay. Okay, 2 problem-solving strategies that we can use today. 15 seconds, what are 2 problem-solving strategies that we can use to help us find how many 1-inch cubes she's going to need? Leo already kind of has one on his paper. What are 2 problem-solving strategies we can use? Turn and talk, go. I'm hearing one of them. Not draw a diagram. Good job, Oliver. And class. I'm loving the discussion that I'm hearing because winner, you all got our 2 problem-solving strategies. What's one that we're going to use today? Oliver. Write an equation. Everybody, what is one problem-solving strategy we're going to use? Get ready.
Write an equation.
And what is the other one? Cecily.
Make it simpler.
Okay, I think I understand where you're going with make it simpler because by writing an equation, we can make it simpler. What is that other problem-solving strategy that we're going to use? Ivanka? Draw a picture. Everybody, what is our other problem-solving strategy? Get ready.
Draw a picture.
Can you please write down draw a picture and write an equation for me? Thank you. Okay, so let's first talk about if we want to draw a picture, making sure that we're sitting in a nice tall ready position. If we were to sketch the smaller cubes in a picture of the 3-inch cube, how many layers would I need to draw? Leo? 3 layers. Everybody, when we go to draw our larger cube, how many layers are we going to draw? Get ready.
3 layers.
Very good. How many cubes would be in each layer? 10 seconds. Turn and talk. Go.
Each layer there would be 3. Another cube has 4. So there'd be 9 total in 1 layer.
And class. So if I know that I need to draw a larger cube with 3 layers, how many 1-inch cubes are going to be in a single layer? Colton.
3 cubes. 9.
9 cubes. Everybody, how many total cubes will be in 1 layer? Everybody, get ready?
9 cubes.
9 cubes. Very good. Now, we're going to try our best to draw this picture. I am not Picasso. You are not Picasso. Drawing a 3D shape on a 2D piece of paper, it's a little bit challenging, so let's do this together. So let's go ahead and start by drawing a square. Honestly, your cube may look better than mine. It may look better. Then I know that we go out. I think I'm doing great so far. Thank you, Jacob. Excellent. Now, Colton just said that we should have 9 cubes in each layer. On our first face for our cube, let's make sure that we can see 9 cubes on that first face. Leo, yours is awesome. You need to come and draw mine. Alrighty, and then again. Alrighty, so this is what your cube, Colton, excellent. Seriously, your cubes look better than mine. And we are ready in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. How can we find the number of 1-inch cubes needed to build my larger cube? 2 equations that I could write. I could do equal groups, or I can use another equation. What about my equal groups? If I know that I have 9 cubes in each layer, what would that equation look like? Sophia? So, remember, when we do equal groups, we have the number of groups times the number in each group. So what would my equation be? 3 times 9 what? 3 times 9 cubes, which would equal, everybody, get ready?
27 cubes.
27 cubes. I don't know why I wrote 22, but I meant to write 27. Let's go ahead and write this equation down. And we're ready in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So you just gave me your equal groups problem, right? We have 3 layers, that's my number of groups, times 9 cubes in each layer. There is another equation that we've just recently been learning about that I could use my 3 inches, right? I would have 3 inches by 3 inches by 3 inches. Oh my goodness, what equation am I going to want to solve for? Cecily? 3 inches, excuse me, times 3 inches times 3 inches. Ooh, what do we call length times width times height? Oh, everybody, get ready?
Volume.
Volume, very good. So pause, I did not tell you to pick your pencils up. Everybody, 3 inches times 3 inches times 3 inches would be, get ready?
27 inches.
Pause, right? If we're talking about volume, right, we're kind of extending this a little bit. When we talk about volume, what is the unit? Everybody, get ready?
Cubic inches.
Much better, right? So 3 inches times would be, again, I don't know why I'm writing the wrong number, would be 27 cubic inches. Very good. We extended our problem solving a little bit. Go ahead and write that down. Now, I took us one step further today and we went ahead and kind of found the volume for what our cube would be. However, I just needed to solve how many 1-inch cubes is she going to need to build her larger cube. Everybody, how many cubes will she need? Get ready?
27 1-inch cubes.
Okay, so pause. I just want to know the total number of cubes. I appreciate those of you who said 1-inch cubes. So we are going to say 27 1-inch cubes as our answer because that is what we were asked to solve for. So one more time, everybody, how many 1-inch cubes will she need? Get ready.
27 1-inch cubes.
Write that down as your final answer and make sure you circle it for me. Give yourself a big red smiley face for problem solving today.